So what you see behind us is a machine that was specifically designed and built at the University of Edinburgh to test the novel materials that our chemistry colleagues are manufacturing throughout the UK for the purpose of designing novel processes for capturing CO2, which is essential for us to then predict how these materials will behave in a process that is coupled to a coal-fired power station.
A lot of people don't really understand the contribution of carbon capture and storage to the energy mix, because we're not talking about necessarily how much energy can you get from carbon capture and storage. What we're really talking about is tackling climate change. You can say actually a pretty good solution for climate change is just to make sure that all the fossil energy you use gets used with carbon capture and storage. You can't carry on putting any fossil carbon in the long run into the atmosphere. The work we do here at Edinburgh covers a lot of different scales. We're running a large UK network that pulls together academics at all the universities working on carbon capture and storage in the UK. We're working on better ways to capture carbon dioxide, and most of all, we're training the people who will take that on, the next generation. We're seeing a need to develop UK's energy system, build it back up again, and we need to bring on the young people to do that. Behind me is Longanic Power Station, owned by Scottish Power. It's the largest power plant in Scotland, and it's likely to be the site of the UK's first carbon capture and storage demonstration. Longanic at the moment is putting out millions of tonnes of carbon dioxide a year, and all of that, or nearly all of that, could get taken away and put out securely under the North Sea. And what's actually really interesting as well, with power plants like this, you can burn biomass. Now the biomass has taken the CO2 out of the air. If you then put it back into the air, it's carbon neutral, but if you don't put it back into the air, you capture it, send it away, then you're actually taking CO2 out of the air. So not only could you reduce emissions, you can actually go carbon negative with carbon capture and storage, particularly at coal-fired power plants. Coal-fired power plants are very good at burning all sorts of things, so waste wood, even sewage sludge and waste like that in the longer run. If we can get carbon capture and storage started quickly on power plants like Longanic, then we've got a reasonable chance of getting a good outcome in global climate change negotiations around 2020. Longanic's important because it's a retrofit project. We can get started quickly building there. It's a retrofit. China's got a lot of existing power plants and those need retrofitting. But if we don't have CCS ready, if we haven't demonstrated that we're prepared to do it here in the UK, then we'll go to China in 2020 and say, guys, cut your emissions. They'll say the only way we can do it is with carbon capture and storage, but we haven't seen that it's been demonstrated how to do it. We haven't seen that you're committed to spending that money, and we won't be successful. But if we can get it done quickly, build up maybe 5 gigawatts of CCS in the UK by 2020, then not only have we cut our own CO2 emissions, but we're making a real statement for the world as a whole.